Okay, so we looked specifically at DNA viral replication using the herpes virus as an example. Now we're going to start going through all of the different DNA viruses, and we're going to start with parvovirus, which is really one of the simplest ones to talk about. This is a really small virus, and most of you probably at least have heard of parvoviruses because you know that within that family of viruses you have viruses that are specific for your dog. And you vaccinate your dog against parvo because that is really bad for dogs. But there's another human virus in this family that is specific clearly for humans, and that's the B19 virus. Now, the reservoir for B19 is the respiratory tract, therefore it's transmitted through respiratory droplets, but keep in mind it's also a naked virus. Now, naked viruses are very sturdy, so what you're going to see for transmission here are also fomites, which means that if I'm up here talking and I sneeze and I get the spray going on, any time you have a naked virus, those can last for long periods of time on fomites. Somebody else comes along, picks it up, inoculates themselves. That is also a really important mechanism of spread. The other thing we really have to pay attention to here is that B19 can also be transmitted by crossing the placenta. All right? So B19 is one of those viruses you have to remember is a congenital infection. Now, pathogenesis for B19 is that the virus actually targets immature red cells. So it infects erythroid progenitor cells and disrupts those cells. Remember, it's a naked virus, so those cells are going to lyse. What results is typically you'll have an anemia, but most of the time it's clinically inapparent anemia unless there's an underlying issue. For example, if a sickle cell patient gets B19, the anemia that's produced there can result in an aplastic crisis. Okay? So the target is the erythroid progenitor. It blows those cells up and does result in anemia that in a normal, healthy kid, usually you won't even probably realize. In a child that has a comorbid condition like sickle cell, it's enough to cause an aplastic crisis. So now we want to talk about the actual disease, B19, and the technical term for B19 is erythema infectiosum. Now, there are also several lay terms for B19. One of those is slap-cheek fever, and you can obviously see where that got its name by looking at the children in this picture. It looks like somebody popped them really hard on both sides of the cheek, and they have this kind of facial rash that clearly gave the disease its name, slap-cheek fever. Additionally, the disease is also called fifth disease. Now, this probably doesn't make sense to a lot of you because a lot of the other diseases that are 1, 2, 3, and 4, we vaccinate for, so we don't typically see them. But this was the fifth of what we would call the classic childhood xanthams. Now, the other 4 included measles, which we vaccinate for, VZV, which we vaccinate for, rubella, which we vaccinate for, and then roseola, which we do not have a vaccine for. So that was 1, 2, 3, and 4, and B19 was the 5th, so they would call it fifth disease. Now, the incubation period is approximately a week, and as far as the illness itself, you'd have a flu-like illness, but the facial rash was going to be what gives it away. After the presentation of the facial rash, that's going to be, the facial rash will really kind of go down and is going to be followed by kind of a lacy body rash. So really, in order to make the diagnosis by clinical means, you're going to have to see that facial rash. If adults get B19, which is fairly uncommon because most of us have been infected in childhood and we typically don't get reinfected as adults, but if adults were to get B19 as a primary infection, they usually get much more serious disease with malaise, a rash, and the arthralgias that are really predominant. The rash itself, and this is an important point because it ties in with immunology again, the rash and arthralgias are due to immune complexes, and remember that relates to a type 3 hypersensitivity. Now, we also said B19 crosses the placenta. So if B19 crosses the placenta, it can affect the fetus, causing clearly anemia. Remember, it infects erythroid progenitors. It also can cause heart failure and hydrops fetalis, in addition to spontaneous abortion. Now, what you need to think about is that we do not have a vaccine for parvovirus B19. And while most of us probably had this as a child, all right, as we become older, and then for females, we get pregnant, we'll probably protect the fetus. But we don't have a vaccine for this. So if somewhere in the vignette or the question that you're reading, it says, you know, the patient was up to date on all vaccines, then you start considering B19, you start considering cytomegalovirus. If they said that the patient is not up to date on vaccines, then you start thinking perhaps maybe congenital rubella syndrome. Okay? Now, you're going to love me for diagnosis and treatment for most of the viruses. Well, you don't worry about a treatment. It's supportive care. Okay? Diagnosis is predominantly made by serology if you're going to get a definitive diagnosis. But for you, that has to be based on clinical presentation. So patient, you've got a 5-year-old child, presents with a fever and a facial rash, malaise, what's the most likely cause, B19, which virus family is this a part of, parvovirus. That's how they're going to ask you this. Okay? Alternatively, again, they can go to the fact that it's a congenital infection.